Good morning, guys. So sorry for starting this off with a red marker, so it's hard to see, but we're going to be focusing today on translations of strictly linear equations. So some of the language might be tricky. So let me go through some just basic first step stuff, then I'll do some graphing stuff, and you'll see this again today in class. So first things first, we know our parent function is f of x equals x, whereas you guys are used to it, it's always y equals x. All right, they mean the same thing. Now, I'm going to go through just how some of these things look based on what is written, okay, so you can understand how to write a translation. A translation means the line does not change size, it just simply changes direction or moves around on the xy axis, but it stays the same slope. That's what translation means. It's different from transformation. So first things first, the first thing says a vertical translation up 6 units. Well, the translation for this would simply be f of x equals plus 6, like such, okay? Now, the reason being is because it's moving up, so that's all you're adjusting right there, all right? So this is just f of x plus equals plus 6, because you're moving the entire thing up 6. That strictly refers to the y-intercept. I did two different types of questions. I want you guys to get used to the language. A vertical compression can be either making it wider or making it taller, like a steeper. This is a steeper line, so this would actually be a transformation because now we're changing the shape of the line itself. A vertical compression by a factor of 1/2. Now we're changing the slope, so now that's going to look like this. It's going to be 1/2 f of x. Okay, and remember, when the slope itself is less than 1, greater than 0, we know that the line gets wider and opens, it's getting more and more horizontal. So vertical compression by a factor of 1/2 is simply this, whereas a vertical compression by a factor of 3 is simply 3 times f of x, okay? Now, the next thing is a horizontal, now obviously greater than 1, we know that it gets steeper and steeper and taller and taller. The next one says here a horizontal translation of 3 units to the right. Now pay attention, 3 units to the right means something different than 3 units to the left, obviously. More importantly, what I'm talking about is, we know this is f of x, because it goes to the right, we do the opposite, minus 3. Okay, remember the opposite stuff inside the parentheses. We'll see where this relates to in just a minute. And the next question says reflection across the x-axis. Well, the reflection across the x-axis is, if it is this way, now it's this way, so it still reflects across the x and the y-axis like we remember yesterday. So this is now negative on the outside f of x. The basic stuff you got to know for that. I'll be back in 1 second to go over a couple more examples. All right, sorry about that. So I did these ones in black for you. So we're going to do these 3 examples, and this relates to what we just went over. So this is how we write the new equations after we follow these translations. So this one says, I want you guys to find the new equation of the translated graphs of the ones I provide with these notes. So for instance, if the original graph of f of x equals x minus 6, and I want you guys to translate f of x up 3 units. Well, the original equation is f of x equals x minus 6, and then I'm just going to add 3. Now again, we don't need these parentheses, I'm not multiplying anything, so at the end of the day, your final equation that you would graph is simply x minus 3. This is how I translate up 3 units from x minus 6 to now it's x minus 3, and it simply just adjusted only that y-intercept. Another one, f of x equals 3x plus 2. I want you guys to do a couple things here. Translate up 6 units and to the left 4 units. So here's how you would do something like this, okay? So if you got the f of x is equal to, you got the original, so I want you guys to translate up 6 units to the left 4 units. So I'm going to do 3 on the outside to the left 4 units. X plus 4. It's always the opposite on the inside here, okay? It's always the opposite on the inside there. And then I still got to do the plus 2, and I still got to translate up 6 units. Plus 2, plus 6, okay? So now just carry out the math and do the distributive property, and then combine your like terms. All right, so this is going to be 3x plus 12 plus 8. So your translated new graph is proper equation of f of x equals 3x plus 20. That would be your new equation after following this translation, okay? And when you graph this, you would see that it would do everything that you said. Everything would be up and stretched over. Now, the next one's a little different, okay? Change my view on this one. Now it says a vertical stretch, all right? A vertical stretch means we're doing something different now, all right? So first things first is I got a vertical stretch means this is now being multiplied by everything over here, okay? And I'm gonna be doing this. So we're doing a couple things. A vertical stretch of 3 reflected over the x-axis, so now this was positive, now this is negative. So now this is a f of x equals negative 3 because I'm doing that reflection, so it's the opposite of this. So multiplying by 3, 4x minus 2, like this, okay? And then I just carry out the distributive property, and I get f of x equals negative 12x plus 6. And that is all you would do for something like this, all right? You'll see examples like this in today's work. It should be relatively similar to what I just went over, and I will see the rest of you guys in class.